Happening, everyone. So these are the final two questions on the mixed exercise that I've set. These question 9 and 10, and these are on those ones that we were doing recently with modelling. Okay. So the problems that we had with this when we did it previously were not necessarily the figuring out the minimums and maximums and things like that, and actual calculus part of it. It's the other bits. So let's try our best to kind of concentrate on just getting a bit more of understanding on these. Before we start, both of these questions are hard, okay? So don't worry if you're still not 100% on these, that you will get there with the more and more practice we do in terms of our just algebra skills, basically. Right, so a wire is bent into the plane shape ABCDE is shown. It's a rectangle and a semicircle, okay, with diameter BD. The area of the region is R. AE is X, so let's mark that on there. AB equals ED, and they equal Y. Okay, so if that is X, remember then that means that the radius of that semicircle is going to be a half X, isn't it? Okay. Find an expression for Y in terms of X, given that we know the total length of wire is 2 meters. Okay. So part A, basically you're told the perimeter of that adds up to 2. So figure it all out, set it equal to 2, rearrange it for Y. So part A, let's have a look. 2 will equal this side, add this side, add this side. So that's 2Y plus X plus this. Now that is a semicircle, isn't it, from there on to there. So that's half of a circle. So we're going to do a half times the formula for the circumference of a circle, which is 2 pi r. And the radius of this circle was a half X, wasn't it? Okay, so let's just tidy it up a little bit. Right, so a half times 2 pi gives you 1 pi. So that's going to be a half pi X there. Then I want Y on its own, so I'm going to get everything over to the side. So I'm going to get 2 minus X minus a half pi X equals 2Y. Divide everything by 2. 1 minus a half X minus a quarter pi X must equal Y. Okay. So part B. Prove that R, which remember was the area, is given by that X over 8 brackets 8 minus 4X minus pi X. So the area here is X times Y plus a half of the area of the circle, which will be pi times a half X all squared. Okay, so let's put this in because we know what Y is now, don't we? Basically what I can do is this Y here I can swap out for that Y. Okay, so the area is going to equal X times this thing in a bracket, 1 minus a half X minus a quarter pi X plus, and I'm going to try and tidy this up, pi over 2 or a half pi times this thing squared is going to give me a quarter X squared. Okay, so that's what I want to do so far. Now I'm going to multiply this out and try and rearrange it all to make it look like this. X times 1 is X minus a half X squared minus a quarter pi X squared plus a half pi. Actually that's going to be an 8th pi X squared there, isn't it? Half times a quarter is an 8th. And then obviously I can group these two things together. Okay, so X minus a half X squared, and that gives me there, this is going to give me, if I take that out, this is going to give me a minus a quarter pi X squared. Sorry, that isn't, that's minus an 8th there, apologies, that should have been. Just wondering why that's going wrong. Right, we're along the right tracks here, aren't we? Because we can see that we've got x over 8. Now I can basically take that out of all this. If I want to take out an 8th x as a factor, I just divide, obviously take the x out as a factor straight away. You can do that, can't you? That's going to turn into a number, that's going to turn into a single x, that's going to turn into a single x. 1, if you're taking out an 8, do 1 divided by an 8th, a half divided by an 8th, an 8th divided by an 8th. Okay? So, I'm just going to work that out and replace it properly because I don't like to look it up there. 1 divided by an 8th is 8. So that x divided by an 8th will give me 8. A half divided by 8 will give me 4. So that will give me 4x there. And an 8th divided by an 8 will just give me 1. So that will give me minus pi x there. Okay? Right, part C. Given the x can vary, using calculus show you're working, figure out the maximum value of r. So at the minute we've got this formula here for, where are we? This one, for our area. And I'd go back to using that one just so we haven't got to figure out, you know, what's going on there with the fact that we've got things inside the bracket and outside the bracket. It's easier to have them all terms like this and no brackets. So we're going to differentiate this. Will equal 1 minus half times 2 is 1. 1 minus x minus an 8th times 2 is going to be minus a quarter pi x. Okay, so we need to set that, because this thing is going to be a maximum, we need to set this equal to 0. So we're going to get 0 equals 1 minus x minus a quarter pi x, and then we're going to need to take the x's over to this side, so x plus a quarter pi x will equal 1. So then factorise out your x from there, so x brackets 1 plus a quarter pi will equal 1. Divide both sides by the bracket, 1 over 1 plus a quarter pi, and let's see what that equals in our calculator. 1 over 1 plus 0.25 pi gives us around about 0.56. Okay, so what that means is that our area, the area will be at a maximum when x equals 0.56. So I'm being asked to calculate this maximum area, so I now sub this back into the formula for the area. So 0.56 minus half, 0.56 squared, minus an 8th pi 0.56 squared. Now in the back of the book and in the solution bank, it does this by keeping everything as a fraction. I can't really see why you would need to do that here, because it doesn't say show that it equals this certain fraction. So I'm going to keep this like this. 0.56, press that as equals. So I'm going to do my answer, minus, oops, brackets 0.56 minus a half times 0.56 squared minus an 8th pi brackets 0.56 squared, and that gives me around about 0.28. Okay, so you figured out that the maximum occurs when x is 0.56. You then sub that back into your area, and that gives you your answer there. Right, let's have a little look then at question 10. Now, question 10 is quite tricky. Okay, so cylindrical biscuit tin has a close fitting lid which overlaps the tin by 1 centimetre as shown. The radii of the tin and the lid are both x centimetres. The tin and the lid are made from thin sheet of metal and of area 80 pi centimetres squared, and there's no wastage. The volume of the tin is V. Show that V equals that. Okay, so a couple of things that you need to kind of be aware of here. When it says that it overlaps it, it means that this basically sits on top there. Okay, so what that means is that we're going to be looking here at the height of only, when we look at the height of the thing, the height will be h plus 1 with this. Okay, I'll explain what that means in a second, but it's important to notice there that you cannot look at this in terms of the lid and the cylinder, the lid and the tin being the same cylinder. You have to look at them sort of separately. You'll see what I mean in a second. Okay, so what we're going to do is we're going to call the height of this thing h. Okay, so because we know that the metal has an area, the total area of 80 pi, we're going to figure out the total area of metal that we can think of on there. So what you will be doing there is the metal that you'll have will be the circle on the top, the circle on the bottom, this curved surface area, and also this curved surface area there. Okay, so pi r squared on the top, pi r squared on the bottom, curved surface area around there, plus your curved surface area around there, that will equal 80 pi. Okay, then given x can vary, use differentiation to find the positive value of x for which v is stationary. So differentiate this with respect to x basically. Okay, and then solve to set it equal to 0 and solve. That gives you the positive value for x for which it's stationary. Prove that this value of x gives a maximum value for v. So figure out d2v by dr squared, sub in the value that you get there, and remember what kind of value must it get to prove that it's a maximum. Once you've proven it's a maximum, sub your value for x back into this formula for v. That will tell you what the actual the maximum volume is, and then determine the percentage of sheet metal used in the lid when v is a maximum. So what you'd have to do there is think about the area, using the x is this value that you figured out there. Think about what area you're going to get there over 80 pi and turn that into a percentage. Okay, it is a lot of work, question 10. So honestly, if I'm going to ask you to pause the video and have a go at it, if you manage to get some of this done, really, really well done. Okay, so pause the video, have a go please, and then come back when you're ready. Right, so the surface area here and the volume are the two things that we're looking at. The volume is going to be the tin, isn't it? The volume is only the volume of the tin, remember, which is pi times the radius squared times h. Okay, which means that's pi times x squared times h. So if we want to figure out some kind of formula for it there, I need to know what this h equals. So that's what I'm going to do here. So the surface area will be circle on the top, circle on the bottom. That's 2 pi r squared, isn't it? Which is 2 pi times x squared in terms of this. Pi r squared will be 1x squared, another pi r squared there, so that's 2x squared. Right, the curved surface area on the top, remember if you imagine sort of cutting that and spreading it out, it will be a rectangle with height 1 centimetre and with width or length the radius of the circle, which is 2 pi r, which is 2 pi x. So the area, the curved surface area there will be 2 pi x times 1, which is just 2 pi x. Okay, the curved surface area here will be the same thing. It will be 2 pi x times h. So 2 pi will be the distance right around there, and you times it by the height there to get the area. And we know this adds up to 80 pi. Okay, so what I want is that h there on its own. So let's just tidy it up a little bit. I can divide everything by pi, and I can divide everything by 2. So that's going to give me x squared plus x h equals 80. So now let's rearrange this. We're going to get xh equals 80 minus x squared. divide everything by x, h equals, sorry, I divided everything by 2 there, didn't I? That should be 40. 40 minus x squared all over x. Now I can put that into there. So v will equal pi x squared times this fraction. Now the fact that I've got an x squared outside there and an x at the bottom of the fraction means that I can cancel those x's. X will go there, that one of those x's will go. So I'm multiplying pi x by these three terms. So that's going to give me 40 pi x minus pi x squared minus pi x cubed, and that's that, isn't it, if I factorise out the pi. Okay, so I've proven what they wanted me to do there. So part B, use differentiation to find the positive value for x which v is stationary. Well, there's v there, so I'm going to differentiate that with respect to x. So dv by dx will equal 40 pi minus 2 pi x minus 3 pi x squared. Now, because I want a maximum point here, oh sorry, I want a stationary point, don't I? Find it where it's stationary. I'm going to set this equal to 0. Okay. Now, before I solve that on the calculator, notice there's pi in each one, isn't there? So I'm going to get rid of the pi's. So 40 minus 2x minus 3x squared means I can just sub that straight into the calculator. Right, making sure that you put your x squared term in first. So I want minus 3x squared minus 2x plus 40, and that gives me x equals 10 over 3, and it also gives me x equals minus 4. I'm going to reject one of them. Which one am I going to reject? Yep, the negative one, because we can't have a cylinder with a negative radius. Okay, so we've now figured out the value of x, or the radius of this tin, when the volume is going to be a maximum. Okay, so prove that this value of x gives a maximum. So part C, so if I want to prove that something's a maximum, I use the second derivative. So let's get the second derivative. So d2v by dx squared will equal, the 40 pi will disappear, that'll just turn into minus 2 pi, and this will turn into minus 6 pi x. So if I sub in 10 over 3, this will give me minus 2 pi minus 6 pi times 10 over 3, which ends up giving you, that's going to cancel with that's leave a 2 there, so it's going to be minus 20 pi minus 2 pi is minus 22 pi. That is negative, therefore it's a maximum. Okay. Part D, find now this maximum value for V. So part D, we now know that when we use x equals 10 over 3, that the volume is a maximum. So I'm going to sub it into this. So V will equal pi times 40 brackets 10 over 3 minus pi times 10 over 3 all squared minus pi times 10 over 3 all cubed. Shove all that in your calculator. And we've ended up there with a negative answer there. How has that happened? I know what I've done. I didn't need those pies in there, did I? Because I put it on the outside, hadn't I? Okay, so I'm going to go back into this and just delete them. Delete that one. Delete that one. Yeah, so I get an answer of 267.62. Okay, for your maximum D. And then part E, I'm going to have to do this here. Determine the percentage of the sheet metal used in the lid when V is a maximum. So what that means is we're again going to use the X as 10 over 3. But we're going to think about our formula up here. What within that formula represented the lid? Okay, so remember that the lid has one circle on it, which is going to be pi r squared. So that's going to be pi times 10 over 3 squared, plus the surface area of that, which remember was 2 times pi times x, effectively times 1, which is just 2 pi x, wasn't it? So 2 times pi times 10 over 3, oops, and we can put all of that all over 80 pi. Okay, so if you figure that out, I mean, we can cancel the pi's from everything there, can't we? So if we do 10 over 3 all squared, that's going to be 100 over 9 plus 20 over 3, and then I want that over 80. So I can just put that in your calculator. 100 over 9 plus 20 over 3 gives you that. Divided that by 80, we get 2 over 9. Times that by 100, and we get around about, I think about 22%, something like that. 22%. Okay, so as I said, I mean, they are both tricky questions, those 9 and 10, especially this one with the idea of the lid and the fact that you can't sort of join them together. If you manage to get any of that right on your own, if you manage to get right the way to the end there, genuinely outstanding work. But any of that stuff, and remember what I was talking about in terms of exam technique, that if you're struggling with part A, but you're looking at part B saying, well, that's asking me to differentiate what it's asking me to show on part A, then you can just skip it and go on to that. Okay, so as I say, if you manage to get any of that right, well done. Any issues, just let me know.